Yesterday, we started talking about significant digits and precision. Remember, the number of significant digits tells us our accuracy, and the place value tells us our precision. We left off with number 7 and number 8, and the more precise value here, if we look at number 7, this has a precision of 0.1, and 0.040 has a precision of 0.001. So the more precise number is actually 0.040. And then for significant digits, for accuracy, 428.0 has 4 sig figs, whereas the other one only has 2. Remember, the zeros at the beginning do not count, but the 0 at the end does. So the more accurate number is 428.0. And then for number 8, the precision for 301,000 would be 1,000. The precision for 300,954 would be 1. So the more precise number is 300,000. And then for sig figs, this first one, 301,000, only has 3 significant digits. We don't count those last 3 zeros. And all 6 numbers count in the other one. So again, the more accurate one is also 300,954. So in an approximate number, the last significant digit is not completely accurate. It has actually been rounded off. So if we've been working with an approximate number, the last number is not completely accurate because we ended up rounding it. This leads to possible error of at most a half of a unit in its place value. So for example, now this is a little different and it's a little confusing because it's different from how we would normally write it. But it says, for example, if we write the voltage as 115.7 volts, we're saying that the voltage is at least 115.65 to 115.175. Any value between these two numbers would round to 115.7. So no more than is the key here. It's no more than 115.75. So when we're finding the value of what it could be, we're going to 0.5 on both directions. So this next example say, round off the given approximate number to 3 significant digits and 2 significant digits. So for part A, 3 sig figs, we would keep the 7, the 0, and the 3, so we would have these 3. So we would keep 7, 0, 3. The 6 and the 0 would change to zeros. Put a comma. For part B, where it says 2 sig figs, we would only keep the 7 and 0. So we would keep the 7 and 0 and put 3 zeros after it. I'd like you now to try 10, 11, and 12. Okay, so this next part where we're doing operations on approximate numbers, we have to follow these rules. And again, we're going to use these rules the entire course. So when we are adding and subtracting, we round with the least precise number. When we're multiplying and dividing, we round with the least accurate number. So for addition, we use precision. For multiplication and division, we use accuracy. Square root of a number is we use the accuracy. And if we have approximate and exact numbers, we only have to look at the accuracy of the approximate numbers. We only have to look at the accuracy of the approximate numbers. You don't have to take the exact ones into consideration. You're going to have a calculator. You're going to use the calculator. You're going to give me the original answer that shows up in the calculator. That way you get partial credit. Then you're going to round according to our rules. So let's start with example number 1. So 73.2, we're using the rules. We are only adding here, and when we add and subtract, we're going to use precision. So keep in mind we're going to use precision. So this precision is 0.1, this precision is 0.0001, and this precision is 0.01. So that means we're going to round to the 0.1. We're going to round to the tenths because that's the least precise number. But we're still going to take our calculator and we're going to add these numbers together. 73.2 plus 8.0627 plus 93.57. I'm going to add those together. And you're going to show me the entire answer that shows up. But then you're going to use our precision rules to round. We want to round to the tenths. So if we're rounding to the tenths, we're going to round at the 8, and the 3 beside it tells us we're going to round to 174.8. That's our rounded answer, using the least precise number. Using the least precise number. Okay, for number 2, we have a mix here. We have division and we have addition. So this division part, we have to worry about accuracy, which accuracy is significant digits. Well, there are 4 sig figs here, and there are 5 sig figs here. The least accurate means we're going to round to 4 sig figs. So I'm going to start by taking my calculator, 3275 divided by negative 60.041. So I end up with 40.5 minus 54.54606019. Never round until the end. Now, what we would do here is, because we have 4 sig figs, right now we would technically round here if we were done. But we're not. Now we have to add or subtract. And the precision for this is 0.1. The precision for this answer would technically be 0.01 if we finished, if we were done and did our rounding, because that's where our 4 sig figs are. So actually the least precise for this next step is going to be to use 0.1. So I'm going to take 40.5 and I'm going to subtract my answer, and I get negative 14.04606019. Write it all out, then do your rounding. So we said we want to round to the tenths, so I'm rounding right here. So my final answer is negative 14.0, and yes, you have to have that 0.0. We're going to do a lot of practice with this because this is critical to what we're learning in this class. We will use this all the time. Okay, so I'm going to stop there. I would like you to attempt 3 and 4. I will wrap up the rest tomorrow. I also want you to attempt all of homework 1.3. I know some of you still can't access some of the stuff in the iPad, but do as much as you can of homework 1.3, and we'll wrap this all up tomorrow.